So good morning, good evening, good afternoon, wherever you are. My name is Vishnudat, and here we are starting OSPF, BGP and MPLS session, right? Or the course you can say. I think that it is going to be almost 40 hours course. But as you all know, we generally do not put higher limit on number of hours. So even I'm not sure that whether this course is going to complete in 40 hours or not. But let's see. But to begin with, it is going to be 40 hours. So you need to spend around 40 classes with me. And it is going to be over 2 months. So let's see how it is going to go. But first thing first, let's think what is the agenda of today's session, right? So here is the agenda. And I have written number 0 here, which is actually having a special meaning, right? And what is that meaning is we are not leaving our characters. We are going to have the same characters like Anjali and Rahul. And if you watch Indian films, then basically you should know about them, right? If you don't, that is perfectly fine, no problem. Just consider them two characters. One is Anjali and Rahul. And if you are following me from TCP days or where we have done transmission control protocol, these two guys knows TCP now very well. It means that they have the understanding of layer 4. And what we are going to do here is we are going to make sure that Anjali and Rahul learns layer 3 also, right? And which is the basic agenda of OSPF, BGP, MPLS, because at layer 3, IP works, and basically we are going to talk about internet protocol and how we can move our packet from one device to another device, which is actually your routing, right? So Anjali and Rahul have decided to learn layer 3 also along with the layer 4. So these are going to be with us during the complete series of 40 hours, right? But I want to tell you what is my idea behind this course, right? So uh, why actually we are learning OSPF, BGP, MPLS when everybody is learning ACI, SD-WAN, and so many other things, right? So what is the idea behind this course? We are going to start with this. Then we are going to talk about what should be the expectations from this course, because most of the people are saying, will you make us expert in OSPF, BGP, MPLS if we take your 40 hours course? So what is my take on that? And what should be your expectations? We are going to discuss this. The third thing is it is going to be routing. And actually I'm a proponent of thinking in terms of why. If you learn any technology, you should understand why behind it, right? So we are going to learn actually why this routing has come into picture. Okay. And if you know that even my company name is BridgeWire. So I believe in bridging whatever why comes to your mind, and that is why the company name is BridgeWire. So we are going to start with why routing, and we actually at the fourth or the last agenda or last topic you can say, we are going to break a routing problem into multiple pieces. We are going to learn those pieces and then we are going to combine. It is our approach always. Doesn't matter we are learning SD-WAN, doesn't matter we are learning TCP. It is all also advisable to break a big problem into multiple parts and learn that parts and then combine it together. So learning approach, learning idea is going to be all same, no problems, right? So this is going to be our agenda. To begin with, let's start with the basic idea behind this course. Why we have decided to choose OSPF, BGP, MPLS to begin with here. Okay. First thing first, I want whoever is attending this course, doesn't matter whether we are online here or you are going to watch these videos offline. doesn't matter, right? I want everybody's networking fundamentals concepts to be strong. Okay. Mainly here we are going to talk about routing, right? And if you want to explore more, means if you want to explore more, if you want to make sure that your switching concepts are also good, I would say that please follow my channel also. The channel name is again BridgeWire on YouTube. Here, basically, you are going to find a lot of things in terms of computer networking basics. For example, if you want to learn how switching works, how address resolution protocol works, this is the channel for you. And basically, we have started from literally from scratch any topic. It doesn't matter whether you are learning their subnetting or how do computers talk in a network. If you want to learn cloud computing or anything, right? There are so many videos available absolutely free of cost. If you want to learn even security also, it is started there from scratch. So just have a look at it. If you go and write Bridgewire and my name is Vishnu, right? Then you are going to find my channel there. So first thing first, I want everybody to be strong fundamentally in routing, and this is my basic idea behind this course. Why I want you to be fundamentally strong. And the reason is, believe me, if you want to learn any technology, any new technology, doesn't matter if you want to learn ACI, SD-WAN, segment routing, SDXS, anything else, right? I'm not talking about Cisco specific technology because SD-WAN could be anything. If you have a solid understanding of these routing concepts along with some portion of switching, believe me, these new technologies are going to be piece of cake for you. I'm I'm from my experience here, because we have just finished an SD-WAN batch, right? There were no prerequisite for that batch. Whatever routing we required, we learned. And you must have, if you have seen that series, most of the times we were discussing the normal concepts of routing, which has which have nothing to what we can say. Uh, those are not related to SD-WAN. For example, to learn SD-WAN, if you understand BGP well, SD-WAN is going to be piece of cake for you. So out of those 30, 40 hours, whatever we have spent in SD-WAN, believe me, we have spent around 5 to 10 hours in just explaining normal routing. Because if you understand the normal routing, you can understand the next generation of routing, which is SD-WAN. So it is really, really simple. Okay. So what I meant to say here is, if you understand the routing well, and we are going to cover the major routing protocol, which one of them is OSPF, which is interior gateway routing protocol. The other one is exterior gateway routing protocol, which is BGP, right? And then a specific type of protocol, which is MPLS, where we are going to talk about how you can efficiently switch the packet in the service provider network, right? If you understand these three things, believe me, I use this word a lot of time, believe me, because I literally want you to understand core of these technologies. If I am teaching you OSPF, you should understand why OSPF has come into picture. The second thing, why they have decided OSPF to be like this. For example, most of the people say that area 0 is the backbone, and then whatever area you have created other than backbone should be connected to area 0. My whole sole point is, why OSPF designers have this thing in their mind that everything should be connected to area 0, right? So if you think from the design perspective also, right, why OSPF is like that, why they have designed BGP like this, then probably you might be able to understand the protocol and the protocol fundamentals. And the whole sole point is to make your fundamentals strong. And the second thing is, if you understand OSPF, BGP, MPLS, the new technologies are going to be piece of cake for you, because most of the new technologies are building overlays over underlay. And believe me, we are just making sure that our underlay is pretty strong. If you do not know about these terms, that is perfectly fine. No issues. The point here is, if you understand the basics of the routing, and you can through OSPF, BGP, MPLS, if you understand that, then these new technologies are going to be pretty easy. The third thing is to improve network design skills, right? I have seen many professionals, maybe some are sitting here also, okay, who are pretty good with respect to troubleshoot a problem or with respect to a particular technology, but they are not sure about the design. Believe me, once again, if you have a solid understanding of the protocols, if you have solid understanding of the technology itself, you can design the network, right? So the basic idea behind this course is to make your fundamentals strong so that you can understand the new technologies and you can design the network based on these technologies. Which technologies? Of course, OSPF, BGP, and MPLS. So I'll make sure that once you have spent 40 hours with me, you are going to uh, build, or you are going to design network based on these technologies. These technologies are not going to be there is not going to be any fear associated with these technologies, and whenever something comes with respect to project in your organization, or maybe any interview, any project, or anything else, you are going to be performing well there. And the reason is because you have a solid fundamentals there. If you want to do the design, if you want to understand any design, again, I'm saying the fundamental knowledge is the key, right? You should understand why this protocol is designed in a specific way. We are not talking about RIP. We are not talking about EIGRP, because these comes into a specific category of the protocol, which is distance vector. We have started with the link state. What these link state or distance vector are, do not worry. Pretty easy concept. We are going to learn. But yes, here we are covering most of the concepts which are pretty standard, right? It doesn't matter whether you are working on a Cisco router or Juniper router or any other router, right? OSPF is a standard. If you understand OSPF, it doesn't matter on which device you are configuring it or where you are going to design the network using OSPF, it is going to be a standard there. So whatever technology we are going to see here are totally standard. It is available on other devices also except Cisco. So this course is not specific to Cisco, but yes, most of the time, whenever we are going to do hands-on, it is going to be on Cisco's router. It is as simple as that. So I believe you all understand the basic idea behind this course, right? To make your fundamentals strong so that you can understand the new technologies and you can design any network on the basis of these technologies. It is as simple as that. Let's talk about another board and let's set your expectations out of these 40 hours, which we are going to spend in upcoming 2 months, right? So here is the point. What should be the expectations from this course? So when people were registering for this course, they had a specific question in their mind that whether Vishnu is going to make us expert in this, right? And here is my thought process with respect to that. That I am not sure what is the definition of expert is, right? And let's take an example that what I think an expert, or basically, can you be an expert in a particular technology, right? So I always give this example. I have spent approximately 15 hours in this industry, starting 7 hours in network security, right? And approximately 8 hours, and basically not, these are not hours, these are years, right? So I've spent nearly 15 years in the computer industry, mainly in the networking side, 7 years in network security, and 8 years basically in routing and switching part. So maybe data center, maybe your normal routing switching stuff, or enterprise technologies, right? So 8 plus 7, 15 years. And I have deployed many networks. I have created many networks based on, let's take an example of BGP, right? But believe me, after so many years, I do not consider myself an expert. And the reason is whatever the BGP is available as a content wise, I know only maybe 5 to 10% of the BGP. You must be shocked that if you only know 5 to 10%, then how you are going to make us understand this technology because you know 5 to 10%. But 5 to 10% of what I know, it is going to be crucial because I think that I am not an expert. And the reason is whenever I finish a book, right? Whenever I finish a book on BGP, suppose I have read this one book on BGP, which is of maybe 400 pages, right? And I felt, and after reading the book, I felt pretty confident. But believe me, when you go at the end of this BGP book, there are going to be 10 to 15 references, right? Means this BGP book is written from those references. It means that, and if you consider a particular reference is another book. Can you read all these 15 books again? And believe me, it is a chain. If you go at the end of these 15 books or 15 references, you are going to find more references, right? So with respect to that, I think that I know only maybe not even 5 to 10%, maybe only 2 to 7% or 6% I know, right? So that means that whether you will be expert in this technology or not, it depends what is the definition of expert. But I want to make sure, I want to do a promise here. I want to make a promise here that once you finish this 40 hours course, I will be making sure that you can work on any project based on these technologies, right? It is it is as simple as that. Suppose your manager comes, right, and say that there is a new BGP project. Are you going to work on that project? And straight away you are not going to say that I need some time to study. You are not going to say that BGP is a big protocol. I need 2 years to complete. I am going to read all the references, all the books on BGP, and then I come back to you to say that yes, now I am ready for the project. That project might be gone at that point of time, right? So the approach should be that you should understand the fundamentals of this technology well. You should not have any fear about this technology. And once that is done, right, you can take any project. For example, your understanding might be there with respect to fundamentals of BGP. Your understanding, maybe you know some of the concept, which are pretty advanced concept. But believe me, you cannot know each and everything about the BGP, right? So let the project come. You are going to see, you are pretty much confident that yes, I know BGP well, but yes, the project can come with some more concepts on BGP which you might not be aware of. And if that is the case, that is easy, no problem. During the project, you are going to have some time to learn new things. So my promise to you is once you are going to finish these 40 hours, you are going to be project ready. I'm repeating myself, you are going to be project ready on any project based on these three technologies, which is BGP, OSPF, and MPLS. Okay. And one more thing, why I have this picture of this road with this is beautiful scenery, right? Why I have created this, and the reason is that if you are planning to go inside these technologies 100 kilometer in depth, or if you want to cover 100 kilometer in OSPF, BGP, and MPLS, right? I am there to be with you in starting 15 to 25 kilometers, right? The rest of the journey, if you have decided that no, I want to read more, I want to be an expert, and again, the definition of expert is not defined, right? I am here to make sure that I can walk with you and there is going to be a solid walk in starting 15 to 25 kilometers so that you can cover the remaining 75 kilometer of the distance, right? But these are going to be your fundamental, these are going to be your core, which I am going to make you, which are going to be so strong that basically the remaining 75 kilometers are going to be piece of cake for you. Okay. So I am here to walk with you during, you can say, 15 to 25 kilometers. The remaining journey is going to be yours if you have chosen to go 100 kilometers in that. So this should be the expectations out of the course. And here is, I'm repeating my promise once again. Once we are done with this course, I am again saying that it is not that I have put a higher cap of 40 hours for this course. If we are not, if we haven't covered or whatever we want to cover in 40 hours, we are going to definitely increase this 40 hours from 40 hours to 50 hours also, or whatever, right? But you should be able to do the projects on the basis of that. I'm not going to make you certification ready. I'm going to make you project ready, right? There is a difference. And if you do not understand that, what is the difference with respect to certification ready or the project ready? Maybe we can discuss it after 1 hour when I open this podium for the questions, right? Having said that, and guys, 20 minutes are gone, right? In setting your expectation, in idea, in explaining the idea behind this course. But believe me, these things are very, very important. You should understand what exactly you are going to get after spending your 2 months, and we are going to meet every day, every weekday, right? So if you are spending that amount of time with me, what you are going to learn, you should know in advance, right? Maybe you by this time you should not agree with me that okay, I do not want to join this course because whatever I was my whatever my expectations were, Vishnu is not meeting. So I am just repeating this thing, and I always say to people that during this course, at any class, I am saying, I am repeating, at any class means if you are in the 40th class or the last class also, and if you feel that whatever Vishnu has promised us, he has not delivered it, I am going to make sure that you get your money refunded for this course, right? Whatever the course fees is, you are going to get. And it is not on the first class. Even if you feel in the last class that no, I am not satisfied with the course, then we are going to return your money and we are going to ask you only one question: how we are going to improve, how we can improve. And nothing is going to be asked anything. If you are not satisfied, you are not satisfied. So having said that, let's move to the next board where we are going to talk about wire routing, right? This is going to be an interesting board because I am taking you into the era of 1980s to 90s 90 when people have developed their own networks. What is the meaning of network? The meaning of network is, suppose we are talking about a university, right? And this university has four buildings depending on what they generally teach in those buildings. For example, maybe this building or this green network, whatever you are seeing, is for engineering. So all the engineering related study is going to be on this building. So what people or what professors, or you can say the teachers of this building, has decided that they are going to create their own network in this particular building, right? And that is why they have group of people here, right? You must be thinking that if we are talking about 1980s and 1990s, then why Vishnu has this picture in which a person is sitting with his laptop? There were no laptop in 1980s and 1990s, and I do agree with you, right? And this is my mistake. So if I have defined a person here, just try to understand that we are talking about a user. This user can be with this personal computer or anything else, or maybe this could be a server. So in the engineering department or in the engineering building, the people have decided that they are going to create their own network, a little network. Maybe this engineering department consists of a teachers. Maybe 20 teachers are there who are going to teach engineering to students, and they have created their own network. Why they want to create their own network? Because sometimes they want to share files, they want to chat among themselves, they want to discuss, right? Because this building is a big building. Maybe this is of 10 floors. This guy is sitting on the ninth floor, this guy is sitting on the eighth floor, and if they want to talk between them, then they should have the network. So in 90s, 80s, and 1990s era, people can create those network with the help of switch. And suppose this person is A, this person is B, and if they want to talk to each other, then they can send the message over this switch, and the switch can deliver the message to the destination. It is as simple as that, right? Similarly, the other streams, right? For example, this is going to be your fine arts building. People have created their own network for this fine art building also. Maybe there we have only two people there who are sitting there and talking. Similarly, maybe there is a law department in which people, maybe the students learn law, right? So they have that specific building for that, and inside that building, people have created their own network. So there was no problem with respect to talking inside a particular network was there, right? In 19, and people were thinking that what is going to happen if this engineering building wants to talk to law building? Because these are two specific network, right? This is network number maybe network 4, this is network number 1. So people were pretty confused that although they can talk inside a building, but there were nothing through which they can talk between the building. So our beloved characters, like maybe Anjali is sitting here, right? And Rahul is a part of law department. But as you know, they want to talk to each other during the university's work hour also. How Anjali is going to talk to Rahul, right? And there is a problem because Anjali and Rahul are part of two completely different networks. One is an engineering network, the other one is in law department, you can say. They have totally different networks, and how to just wait a minute, guys. And how to route the packet between them, it is going to be interesting. So there must be something at that point of time which people are working on, and believe me guys, you might not be able to understand. This was a problem at the time of 1980s. This is not a problem in our current period, right? And the reason is, if you want to route between two different networks, just buy a router and you can do that, or just buy a layer 3 switch also. That is also capable of doing it. It is as simple as that, right? But during that era, during the 1980s and 1990s era, that was really a problem, right? People were building their own networks, and now there is a need to connect the networks. And that is where a new device comes into picture, which is actually bridging these gaps, right? What were the gaps? The gap was that how you are going to make sure that Anjali is going to talk to Rahul, which are part of two different departments in the same university. And believe me, there is the story of Cisco also. I'm not sure how authentic that story is, but the Cisco founders, right, were working in two different buildings in the Stanford University, right? I think the name is Ben, and I totally forget the name of Cisco's founders. And one of them was in a particular department instead in Stanford University. The other one is in a different department of the Stanford University. And basically they wanted to talk, and that is where they thought about this gateway, although they took help of one of the professors also there. But once they have developed this router in their living room, right? I'm again saying most of the companies are start means you have heard about that Amazon starts in the garage, right? Microsoft starts in the garage, but it is not the case that every company started in the garage. Some started in the living room also, and that is Cisco, right? So the first router which was invented there, first commercial router I'm talking about, which is the first product of Cisco. Also at that point of time, they were calling it a gateway server, right? And that gateway is actually connecting two different networks. So now the packet from this network number, you can say x dot 0, can go to this router. Router is going to see the packet from the Anjali, and it can decide on the basis of that, okay, it is going towards Rahul, which is in the different building. It is going to move or forward this packet here, and now the switch can deliver the packet right here towards the Rahul. It is as simple as that. So the router job was to interconnect various networks. And now in today's world, we know this individual network as a LAN, which is local area network. So this might be local area network 1, this might be local area network 2, right? And if somebody is connecting them, that is your router or a layer 3 device. I should not say a layer 3 device because we do not know the definition. What is the meaning of layer 3 device? So just leave that part. But from this point, you should understand why we need why we need a device which can actually do the routing. And the reason is because there were many LAN networks created in the era of 1970s to 1990s, and there was need of something which can interconnect these networks. It is as simple as that. And that is where we need the router. Okay. So this is actually how the router came into picture. And now the time is already 30 minutes. We have already spent 30 minutes. So what I would like to do here is I would like to take a pause. I would request you guys to talk, or if you guys have any questions regarding whatever we have discussed till now, please do ask. Maybe that question on your expectations out of the course, or basically the basic idea why we have built this course, although we haven't learned anything in terms of technology. And it might be the case that in starting 3 or 4 classes, I even don't take the name of OSPF, BGP or MPLS, right? Because we must be covering some of the concepts which are important, necessary in learning those OSPF, BGP and MPLS. So it might be the case in next 4 lectures or in next 3 or 4 class, I'm not going to talk about anything on OSPF. Maybe we are going to make our fundamentals strong to learn these 3 routing protocols, right? Having said that, please unmute yourself, ask any questions regarding this course or whatever you have doubt, and we can spend next 3 or 4 minutes on that. So I could see that there are question from Vishnu Rajendran. Please, Mr. Vishnu, ask your question.
Yeah, hi, good morning, sir. First of all, thanks for conducting this course. Now, coming to the question, what was the significance of IP addressing when there was a time where we didn't interconnect with these networks? For example, in our image that we were depicting here, now there are 3 users in the first image, right?
Yeah.
Engineering department.
Yeah.
Now, at the time of when we were designing this blocks of departments, what is the use of IP address here? Because they simply connect with the MAC addresses, and switches will be happy to connect them using the MAC addresses. So should we understand that when we invented this routers or when we invented this routing concept, at that time only IP address came into picture, or the understanding should be corrected?
Yeah, this is again a pretty, I would say it's a great question. And thank you so much for asking it. And believe me, I have created a 1.5 hour video in explaining that only. But if you have asked me, let me explain you little bit of history behind it, right? So at a particular moment of time, there were two different protocols which were on which the people were working. The OSI protocol, right? Or you can say OSI model and the TCP/IP model. So most of the times in this course, we are going to talk about TCP/IP, although there is a specific model which is more advanced, superior as compared to TCP/IP, which is OSI. But that is only for the reference, and we always work because, and there is an interesting story because the people who were developing the OSI, right? They were more, they were getting more fund from the government. They have the pretty high backing from the higher officials. They are larger in numbers, but still TCP/IP was the protocol which is there, right? So to answer your question, we are talking about 1970s era, right? Where actually people were working on this technology, pretty cool technology, which is Ethernet, right? And along with that, we were developing a protocol which is TCP and IP. And that is exactly where this layering approach comes into picture. And your question is really, really awesome. That if two computers want to talk to each other, right? Maybe it is A, we have a switch in between, right? And maybe we have a computer which is B here. If they want to talk to each other in a particular network, do we need IP address at all? Because switch does not understand IP addressing, right? So basically, if you talk about, if we say that this network is the Ethernet network, right? Which people are working on in 1970s. They have created this network. They do not know what is the protocol at the higher level. For the Ethernet, whatever is coming doesn't matter whether it was the IP or anything else. Maybe we have anything else here, right? Suppose we have IP right now or any protocol which is not IP. To Ethernet, whatever this protocol is, this is just the data, right? And here in Ethernet, what we are going to do is that basically we are going to put a destination MAC and the source MAC. Switch doesn't have to deal with whatever the data inside. It is going to make its decision on the basis of destination MAC address, and it is going to forward. So your question is absolutely correct. Why do we need IP address when we do have only when we want to talk inside a particular network? And the answer is absolutely, we do not need IP address at all if we want to talk about the Ethernet. And that was the problem during that era, that there were many Ethernet networks there because people were talking from A and B using the switch easily, right? But the TCP/IP developers were having a slightly higher overview, or you can say they are having a bigger vision of the communication. They understood that there are going to be many such networks, but how we are going to interconnect them, what is going to happen if we have two different networks and if you want to connect them. And that is where basically that layer 3 comes into picture. So whatever we are going to discuss here is the layer 2 portion. Believe me, there is going to be a specific classes on that before we start even OSPF. So do not worry, your observation is absolutely correct. We are talking about a problem which was there in 1970s because Ethernet was there, right? And it doesn't require any IP address. And if we do not need any IP address, then what is the whole sole point? We need IP address when we are going to talk we going to make two Ethernet networks talk between each other. And I would recommend you to just have a look at this video on my channel, which is comparing OSI model with TCP IP. And the second video is basically why do we need IP address if we already have MAC address, right? MAC address is unique, right? On the basis of it, I can do whatever I want. Why do we need two addressing in TCP IP model, right? If you combine these two videos, your knowledge is going to be perfect. But believe me, whatever we are going to need in the routing section or OSPF BGP MPLS course, I'm going to explain you, right? But I am the problem is in this class I cannot explain everything, but you have to believe me that in upcoming sessions we are going to cover this. But your observation is absolutely correct, Vishnu. I hope some part of your question has been answered, right, Vishnu?
Yeah, yeah, you have definitely answered most of my questions, sir. And also, thanks for the references. I will do check it out.
Yeah, please do. And that comes under the interview preparation series. It is available in Hindi as well as English, any language in which you are comfortable. Just have a look at it. And you will be amazed to see that why I took 1.5 hours in just explaining why this OSI model and TCP/IP model. Why do we have TCP/IP if we had OSI or the vice versa? It took me approximately 1.5 hours, but those stories are awesome. And exactly there you are going to find your answer also because the answer lies in history. See, these protocols, whatever we are learning now on, have been started building from you can say 1970s or even way before that means around 1960s we had the computers, and then there is a need of connecting those computers with each other, right? If you do not understand that, then basically it is really difficult to understand that why do we need these two addresses, because these two protocols were developed parallelly. Somebody was working on Ethernet, somebody was working on TCP/IP. TCP/IP guys have a bigger vision. They have incorporated Ethernet also, so that they are saying that let's make this Ethernet a part of our L2. It doesn't matter what is there in upper protocol. It is just going to take that as a data and it is going to forward it. It is as simple as that. Now I could see one more question, one more hand raise from Mr. Syed Fahim. Please do ask your question if you have any.
I'm audible, Krishna?
You are.
So, can you also like refer us another resource like documents or books which maybe you have used to learn these technologies after the class?
Yeah, actually, my sources are multiple, but yes, books are the only ultimate source which I have. And you need to, means if you really want to go deep into a particular technology, you should consider reading a book instead of watching it 10 or 20 hours, 20 minutes video on that, right? People, because they are having less time, that is why I feel they do not spend time on reading books. So definitely whatever I am following, I am going to give a reference to you, right? But if you guys have any question with respect to what should be the expectation, as I mentioned clearly, or the idea behind this course, or if you are not agree with respect to a particular point, please do ask. Anybody else? Okay. Yeah, Mohit.
Vishnu, this is Mohit.
Yeah, Mohit, please.
So, as you mentioned that these are the basic of basically, not the basic, basically these are the foundation. These technologies are the foundation of the technologies of like software-defined access, SD-WAN, Cisco SD-WAN, and ACI, all these new technologies, what we are hearing and coming, and we are seeing lots of projects are coming.
Mhm.
So I just wanted to understand that after that you have, you are planning to give trainings on those technologies as well.
That is the whole soul idea, and thank you so much, Mohitji, you have asked this question. The idea is that when I was teaching multiple students or multiple professional this SD-WAN, I figure out that it would be great if everybody understand these technologies. So definitely, as soon as I finish this course, the world is open. Maybe we are going to I'm not sure whether I will start with the ACI first or SD access first, but definitely just whenever we are going to complete this series, we are going to start with these new technologies. And believe me, if you have a solid understanding of whatever we are doing in next 1 or 1.5 hour, sorry, one and a half months, 2 months, those technologies are going to be understanding those technologies are going to be pretty easy. So this is the whole sole idea. Let's cover all the basics first, and then basically move towards those technology, because this is my experience while teaching SD-WAN. People do not understand the basics and they say that SD-WAN has some problem. It is, for example, there is a specific technology in NAT, and there is everywhere. It is there in Cisco, it is there in everybody else. Whenever I go and do projects, people say SD-WAN NAT is not working. NAT is NAT. It is really does not depend on any technology. NAT is there from so many years, right? But problem was we had a specific problem in understanding NAT, and that problem we are taking out on SD-WAN. That SD-WAN NAT is not working. I would say net understanding was not there. So that is why if you learn OSPF BGP then and some portion of switching, then probably the ACI part is going to be very easy for you. Similarly, for segment routing, if you understand BGP, OSPF, MPLS, it is going to be very easy to understand segment routing. So the whole sole idea is this one. We are making sure that the fundamentals are strong so that on those fundamentals you can build the new technologies. And thank you so much for asking this question. Anybody else?
One more question I have. So when you talk about BGP, so you will be discussing all the real-time scenarios where BGP can be used, BGP and OSPF
Most of
and
them.
MPLS.
Yes, most of them.
Okay.
Most of them. Basically,
Because that's how,
Mhm.
since I'm coming from solution architecture background, and so that would be really helpful to understand and relate with. Like these are the real-time scenarios which we come across,
yeah,
on daily basis. That's where we can fine-tune the routing and use this stuff or that stuff.
yeah, that is why basically probably we are going to spend 10 hours in learning the fundamentals and the last 10 hours in actually discussing those scenarios, right? In the Hindi session, somebody also asked me that uh, whether we are going to do some hands-on exposure also. These technology doesn't make any sense if we do not do hands-on, right? So probably once we have learned some of the concepts, maybe what I will do is I will be giving you the UNL files, right? Or if you are not aware about the UNL file, then I would like to tell you here is that whatever we are going to learn, we are going to see those things in actual environment, right? Or on a simulator, and we are going to use Eve-ng for that. And interestingly, uh, this Eve-ng can be installed on any device. It is just like your GNS. If you have worked in GNS, Eve-ng working is going to means understanding Eve-ng is going to be pretty easy for you. So whatever we are going to learn, maybe I can give you some UNL files, and if you import those files into this Eve-ng software, you are going to get the topology, and you can practice on that topology. So we will be whenever we are going to start OSPF, we will be taking a specific topology in our mind, and we will be learning from those topology. So whenever you want to do some practical, just open that Eve-ng file and you can start doing it. Okay. So I think I am able to answer your question, Mohitji. We will be
Yeah,
covering.
thank you,
Yeah.
Vishnu. Yeah, thank you, Vishnu. Yeah.
Anybody else, guys? So maybe we can take the Burak question and Satish Kumar question at the end of the session, maybe after 12 or 14 minutes. So sorry, guys, I will be taking your question just after 15 minutes. Let me complete whatever we have in next few boards. So here you go. Our approach of learning doesn't matter whether we are learning network security, whether we are learning ACI, SD-WAN, SD access, the approach is going to be same. Here we are talking about routing. We are talking about routing problem, right? It is going to be easy to understand this routing problem because believe me, people have been developing routing from 1980s and it is under development till now. Although we have some cool protocols like OSPF, BGP, right? But you are going to see the enhancements coming, right? So whatever people have developed, and maybe these people are more than 1,000, 2,000, right? Over the course of these 40 years, we are going to learn them in 40 hours, right? So it means that you can think about that how we are going to simplify it because everything is there, right? So we are learning a huge thing, you can say, because this is the effort of many people over the period of 40 years. And we have some pretty nice book written. We have some pretty good videos, pretty good content available on these technologies. But the idea behind them is if you can break the problem into smaller problems, and if you pay close attention to the smaller problems and combine them, then the problem can be solved. So try to understand that this routing protocol or the routing problem is like a puzzle. It's a big puzzle, right? And if you want to solve this puzzle, what we are going to do is we are breaking this with a hammer, this routing puzzle, right? And as a result of it, we are going to see that there are multiple things which come out. We need to understand what is next stop. We need to understand what is IP subnetting. We need to understand on what basis routing decisions have been made inside a router, which is a routing table. We should understand what is layer 2, what is layer 3, how a frame is dealt with, or how layer 2 deal with the frame, or how switch deals with the frame, or how packets, how router takes a decision that where to forward a particular packet, how to switch the packet, right? We need to understand what is happening at every layer, mostly from layer 2 and layer 3 perspective. And believe me, we need to understand address resolution protocol also. I can have one single class on all these things, right? You must be wondering that if I am teaching you routing, right, why I am not talking about neighbors, why I am not talking about how routing updates are going from one place to another place, how keep alive messages are there between these neighbors, how the shortest path have been calculated, because most of the time we have learned these concepts in routing which are absolutely correct, which we also are going to learn. But believe me, even before that, we need to think, we need to build a mental model that why behind, we need to build a mental model in which we need to discuss or understand these parameters also, because every routing protocol doesn't matter whether it's a OSPF, BGP, you are going to see all these things. Next stop, routing table. You are going to see how a particular router is resolving address resolution protocol, how it is generating ARP. You must be confused here because you have heard about that address resolution protocol or ARP messages are broadcast messages, and routers generally do not forward them. And absolutely right. Routers do not forward ARP message from one network into another network, but they can generate ARP. And it is going to be very important piece of routing itself. If you want to understand static routing, believe me, address resolution protocol with proxy ARP functionality is going to be there. If you do not know these terms, perfectly fine, right? If you do not understand proxy ARP, that is fine, but you should understand address resolution protocol. So what should be my approach here? The approach is going to be that we are going to learn these fundamental things first, Then we are going on a specific routing protocol, which is OSPF, which is the link state routing protocol. Why it is link state, we are going to explain you, right? Before even reaching there, neighbors, updates, and then basically uh, their neighboring state, and then those link state databases, LSAs, how to calculate we will be learning them for sure. But before them, we need to understand these 5 things, right? These are going to be very, very important. So approach we are taking is slightly different. And as I promised, whatever you are going to see here, it is going to be slightly different. But at the end of the day, the goal is common, that once we spend 40 years, we should be pretty much comfortable with these 3 technologies, which is OSPF, BGP, and MPLS. Having said that, let's talk about the first thing, which is IP subnetting. Here is the problem also. I can take 1 hour session on each of these circles. Next stop, IP subnetting, routing table, address resolution protocol, TCP IP and layering, right? But believe me, I have created videos on all these things. And that is what I said, that it is going to be good if you see those videos. I have mentioned, I have forwarded you all the links to those videos. I think those are only 3 or 4 videos of 1 or 1.5 hours. One is dedicated on IP subnetting. One is dedicated on TCP IP layering. Right? The one is totally dedicated on this address resolution protocol. Right? But does that mean if you do not go through those videos, you are not going to understand anything here? No, whatever is going to be required with respect to IP subnetting, I will cover here. But as you all know that if a great content is already available on IP subnetting, please go and watch it. So where exactly that is, I am going to showcase you here. I am opening my browser just to let you know from where you are going to take it. So just open YouTube here. Okay. Just type here Bridge by Vishnu. There you go. And this is my channel. In that channel, basically, you have these playlists here on top, right? And in those playlists, I'm in whatever language you are comfortable. For example, Hindi Network Interview Preparation Series. Similarly, we should have in English also, which is right here. And you can see here all the videos. I'm talking about specifically the video number 2 here, Network Interview Questions Series Part 2 Subnetting. So although I started this series as a to discuss whatever the questions questions asked during network interviews and how basically you are going to answer them, but believe me, there is much more than that. We are going to study the deeper concepts here through those questions. So you should understand that subnetting is there. How basically during the intra-subnet process I have explained complete address resolution protocol. Then why OSI model if we already have TCP model? This is going to be very, very important for you. And then why MAC address if we are already having IP address? These are the things which you should understand. And before we even come together to learn OSPF-BGP-MPLS, please go and watch those videos. If you don't, it doesn't mean that you are not going to get anything. Whatever is required, we are going to cover here, rest assured. Okay, but most of the time I have seen people curious about understanding, going into the deeper side of the technology. If you want, please watch those videos. Having said that, what we are going to do is we are going to spend some time on each of these individual puzzles like IP subnetting, TCP IP layering, routing table, and then we are going to start the first topic, which is going to be OSPF, right? But believe me, it is going to take next 2 to 3 classes before we move actually into the OSPF. So having said that, let's move to the new board, which is IP subnetting, right? And here you can see that I have just copied the previous diagram, right? And we have 4 subnet here. This is my network number 1. This is my network number 2. This is my network number 3 and network number 4. And these are again maybe the building of those Stanford University or any university, right? People have created their own networks there. What is the meaning of creating their own network? Let's talk about this network, network number 1, which is 192.168.1.0, right? Let me move the board slightly here. So we are talking about 192.168.1.0/24. What is the meaning of it? The first thing first, an IP address does not have any meaning unless you specify a mask on that. For example, if I talk about an IP address which is 192.168.1. maybe 100, believe me, it doesn't have any meaning unless you write something after this slash, which is 24. What is the meaning of it? The meaning is that basically this IP address, you all know this is a 32-bit number, right? And we have divided it into 4 parts. And if we divide 32 into 8 or 4 parts, we are going to get 8 bits, right? Here 8 bit, here 8 bit, 8 and 8. If you combine them, it is going to be 32. And with 8 bit, you can write the number between 0 and 256. Why? Because if you have single bit, you can have 2 combinations, 0 and 1. If you have 2 bits, you can have 4 combination, which is 0, 0, 0, 1, 1, 0, 1, 1. Similarly, you can say if you have 8 bits, you can have 2 to the power 8, which is 256 combinations, right? So basically, and here is the problem. The problem is whenever we start talking about IP address, we talk in bits, in binary, right? But as a humans, we are not trained to do the binary mathematics, right? And the reason is from the childhood, everybody talks in terms of decimal. And actually, this is not the problem because everybody understands decimals, right? What is the meaning of decimal? The decimal number system is in which we are comfortable from 0 to 10, right? 0 to 9. This is my decimal number system. But when something comes with respect to IP addressing, we start thinking in zeros and one, and that is where the problem is. That is where we make the mistake. Can't we understand IP addressing with this decimal number system? We can, and that is where my video is coming into picture, right? And that is the time I have taken approximately 25-30 minutes there. If you see the Hindi video, it is going to be 1 hour length. So there I have specifically talked about that you should not think in terms of binary because we are programmed to do the mathematics in decimal, right? So just try to understand here. If we have 8 bits here, we can have numbers from 0 to 256, and that is where basically with this 8 bit, I have made this decimal number, which is 192. Then with the second bit, second 8 bit, this is 168. The third one and maybe the fourth one is 100. And now I have written a /24 after it. What is the meaning of it? The meaning is that the starting 24 bits or starting 3 octets represent the network. And the last 1 octet represent the host. You must be thinking that why Vishnu is teaching us all these things. Because I start absolutely from scratch. I know in this group that there are people who are having only 1 year of experience or maybe 0 years of experience, and the people are having 20 years of experience too, right? But the approach is going to be same. We are absolutely starting from scratch. I presume that you guys do not know anything. So if you are having 20 years of experience or maybe 15 years of experience, maybe you know all these things. Maybe it's a brush up for you, or that is fine, right? But if you are having 1 year of experience, then maybe you do not know all these things. And if you don't know, no problems, right? So what is the meaning of this network number and host number? The meaning is straightforward, simple. Let's talk about this network in slightly detail, right? The number is 192. Let me write with the red pen here, 192.168.1.0/24. As I mentioned, it doesn't have any meaning unless I write this /24. Then, and the meaning of this /24 is that 192.168.1 starting 3 represent the network bit, and the last one is represent the one, right? The host one. So in the last octet, what exactly the numbers can be? In the last octet, the number can be .0, .1, .2. You all understand this, right? And if I say here 192.168.1.1, 192.168.1.2, similarly, what is going to be at the last number? The last number or the last IP address is going to be 192.168.1.255, right? We haven't done anything. We have just specified all the IP, all the numbers in the last octet. And what all those numbers? Those are from 0 to 255. Actually, these are your IP addresses, right? All these 256, because from 0 to 255, the IP addresses are going to be 256, right? But here is the thing. The thing is that the first IP address and the last IP address inside a particular network, this is your network, right, is a special number, the first one and the last one, and we call the first number as the network number. That is, I'm again and again saying that this 192.168.1.0, which is the first IP address of this network, is actually the network number. We are defining network on the basis of first IP address. Similarly, the last number, which is 192, I'm again writing 168.1.255, is the last number, and there is a special meaning. We call it as a broadcast address. You have heard about it, right? And what is the meaning of that? The meaning is really, really important. So suppose I have this network here, right? A big network, a single network, which I am denoting with this IP address 192.168.1.0/24. What is the meaning of it? The meaning of it is that whatever the computers I have inside it can have IP address from this range, from .1 to .254. Why? Because .0 and .255 is a special number which is reserved, right? One is reserved for the network number, which I am writing it here, and the last number is reserved for the broadcast address. So whatever the IP address is remaining, so I cannot have .0, right, which is the first IP address, and I cannot have 255, which is the broadcast address, assigned to this host. But apart from these numbers, from .1 to .254 means 254 addresses are part of these network. It is as simple as that, right? I can assign this host or the computer as an IP address as 192.168.1.10. Maybe this can be .11, maybe this can be .200. How many maximum hosts I can have in this network? I can have maximum 254 hosts assigned, right? So if I say 192.168.1.0 is a network, you should understand that this network contains 256 hosts, out of which .0 and .255 is a special number, and remaining numbers are just I can assign to anybody. But what is the meaning of this 255? The meaning is simple. If this guy, if .110 sends an IP packet to an IP address 192.168.1.255, it is going to be received on it is going to be delivered to all the hosts from here to here, from here to here, everywhere, right? Because this is broadcast. What is the meaning of broadcast? The meaning of broadcast is if I say something, it is coming to everybody which is part of this network. And who are part of this network? 254 hosts are part of this network. Although I have drawn only 4, but there could be 254. If I send an IP packet at 2.255, it is delivered to everybody inside this network and only inside this network. Now, if I talk about subnetting, and if I say, now you understand, right? You understand that 192.168.1.0/24 is just nothing. It is having 256 hosts, out of which 2 numbers or 2 IP addresses are reserved. Now, if I say you need to, this is 24. Now, if I say you need to divide this network into 2 parts, what is the meaning of it? The meaning is that I want to divide this complete network, whatever it was, right, into 2 parts. One is left hand side, the other one is right hand side. And you all know that if you are going to break this 256 into 2 parts, it is going to be 128 each, right? See, we are doing calculation in decimal. And that is what we are doing subnetting. Similarly, if you talk about this 128, the 2 numbers are going to be reserved. The first IP address which is going to be 0 and the last IP address which is going to be 127, these are going to be reserved. And what the number of hosts we have? We are going to have hosts from 1 to 126. It is as simple as that. Similarly here, the numbers are going to be start from 128 to last 256. The first number is going to be your subnet. The last number is going to be, this is 255, is going to be a broadcast, and the remaining 100 and maybe 26 are going to be assigned to this host. Maybe somebody can say that, can you divide this subnet into 4? Yes, absolutely. If you want to divide 256 into 4 parts, you know that you are going to create 64 network, right? A network that contains 64 hosts. If you combine them all together, it is going to give you a result of 256. I am pretty sure that I am explaining you all these things in a pretty quick manner, but there is a complete video if you want to understand. Most of the time we are going to talk about /24 here, but it is not the case that you are going to see everything like this in the real environment. What is the meaning of /25? What is the meaning of /28? What is the meaning of /32? You can understand this thing. But believe me, with respect to subnetting, whatever I want to explain, whatever you should know with respect to this this course, this much is enough, right? But please do watch my videos on subnetting. It is going to help you, right? Because you can argue with me, now there are subnet calculators. We just need to feed my value and how many subnets I want. It is going to give me the results. That is perfectly fine. But believe me, if you understand the logic behind it, it is going to make you more aware with respect to IP protocol, how IP is going to work. So before coming to tomorrow's class, I would expect if you can or maybe over the weekend, I would expect that if you can spend just some time on my channel in watching the subnetting video, it is going to be great, right? So having said that, as I can see, the time is already 1 hour and 13 minutes. I would really like to take a pause here. Okay, I am open for the questions, and I would like to start the question with Mr. Burak because Burak was asking something and we didn't have time at that point of time. So Mr. Burak, please do ask your question. What is your question?
Hello, Vishnu. Actually, it's not a question. It's my thought. My thoughts. I thought that it's better to make a hands-on lab after each class. Maybe you can give us a homework for each subject after each class. For example, for design perspective or for hands-on perspective. That's my just a thought.
I understand that most of the time I would be working on a particular topology, but believe me, it should be your imagination what you would like to do. So maybe some part of the things that I can tell you that, dude or guys, just enable OSPF in this complete topology. That could be your homework, right? And then I can say that maybe I want to tweak the path using the OSPF cost. That could be your homework. But I would not, I really do not want to limit your imagination, what you can do with that particular topology. Okay. So we would be learning a lot of things. So you are free to do whatever you want. But yes, if everybody agrees, then we can always say that these are the some specific tasks which you need to perform as a part of OSPF lab. Okay?
Maybe.
Yeah.
Yeah.
Oh, yes, Mr. Satish, please do ask your question.
Hey, Vishnu, am I audible?
You are.
Yeah. Hey, I have a couple of questions.
Mhm.
One is, let's on the when you were mentioning that we are going to learn fundamentals, right? So is that part covers that like in, let's say in OSPF, like the internal part, like how do they learn routes? They are calling different concepts, right? That LDA, LSA, different types of.
We are going to learn
Uh,
everything. But in
okay.
starting 4
Good.
class, maybe I won't be taking even name of the OSPF because we will be
Oh,
learning. So before understanding OSPF, let's create a mental model. Let's set our mind that how we are going to learn OSPF. If we learn all these basics, then basically OSPF is going to be piece of cake for you. So there must be some homework before learning OSPF, right? I could have straight away talk about neighborship, maybe those LSAs, but believe me, I want to set a context first and then want to talk. And you will be amazed to see after spending these time in these starting 4 classes where we are not going to talk about BGP MPLS, but whenever we are going to start OSPF, it is going to be, you would be thinking that I know all these things in advance. It should be like this. But yes, we are going to learn everything. Whatever I see
okay.
as a part of most of my projects. Yeah, go ahead.
Yeah, and when you were see that there is a slide behind this, right? That breaking that subnet and dynamic routing. So I did not see that multicast in that. So is it something like would be somewhat to required to understand about the
No, multicast
multicast?
actually we are not covering because believe me, if I start multicast maybe as a part of some other course, because multicast is totally different way of route the traffic, right? And that is where people get most confused. I can say that,
Yeah,
yeah.
that's where I'm coming. Like because some part of that is used in these protocols as well, right? But at least we will be covering
At least that
those
part,
in whatever.
definitely. The layer 2 multicast I
Oh,
am going to cover 101%.
okay.
Because if I say that OSPF is sending the packet at 224.0.0.5, what is the meaning of it? Absolutely, I am going to cover it. No issues.
Okay. Thanks.
Right?
Thanks, Vishnu.
But most of the times in our layer 2 environment, these multicasts are treated as a broadcast. So still a gray line there, but yes, I would really like to cover how layer 2 multicasts work. Okay, but not routing at all, not multicast routing. Yeah, go ahead. Anybody else? Okay, tell me, am I audible, guys?
Yeah, yeah.
Perfect. So if you don't have any questions, perfectly fine. We can meet exactly after 24 hours. I know tomorrow is the Saturday, but the schedule of these courses are like this, that We the English classes are going to be starting on Tuesday morning, and that is why it is till Saturday morning, right? So 5 classes we are going to have per week. Tomorrow we are meeting, guys. You all should know about it, okay? Tomorrow, early morning, 7 a.m. in the morning, Indian time. Let's meet again. But I think we have a question with the from Kamal. I think Kamalji. Yeah, please go ahead, Kamalji.
Hi.
Yeah.
Yeah. Hi, Vishnu.
Mm-hmm.
Actually, my question is regarding the course content. What are the topics you will be covering in each technology?
Yeah, and that is basically strangely I haven't thought after OSPF or BGP till now. I have something good in my mind, but maybe unfortunately I haven't created any document out of it, right? So what exactly we are going to cover, maybe you need to patiently wait for that, learning everything along with the path. But if I give you a high level overview, then whatever I have done as a part of means in my experience, means my 15 years of experience, whatever I have deployed most in BGP, whatever I have deployed most in OSPF, in MPLS, we are going to cover it. So that whenever, see, industry is going to be remain same. If you go into the enterprise network of any company or OSPF network of any company, mostly these are going to be used the same thing. Maybe some customer has some different requirement, and that is why we have different functionalities. But most common functionalities of BGP OSPF which we have implemented over the course of last 15 years, I'm going to explain you that. But I haven't I really haven't come up with the content yet for MPLS and BGP. But believe me, it is going to be good. Yeah. Anybody else?
Recorded sessions.
Suresh, I am having really hard time to understanding your voice and understanding. Can you please repeat?
Access to the recorded sessions.
I couldn't get it, but I think you are asking about the recorded sessions. So recorded sessions will be provided by 7 p.m. today, if you're asking this.
Yes. Thanks.
Okay. Anybody else? No, yes? Perfect. Thank you so much, guys. Thank you so much for being part of this course, and see you tomorrow. Bye for now.
Yep.
Bye.
Thank you, Vishnu. Thank you, guys. Bye-bye.
Bye. Bye.